Hello everyone. Welcome to the solution of LeetCode problem 2958 named length of longest subarray with at most k frequency. In this problem, we are given an integer array nums and an integer k. Now, the frequency of an element x is the number of times it occurs in an array. And here, the array is called good if the frequency of each element in the array is strictly less than or equal to k. Now, we have to return the length of the longest good subarray nums. And here, is a subarray is a contiguous non-empty subsequence of element within an array. Now here, for the first example, the array contains 8 elements, which is 1, 2, 3, 1, 2, 3, 1, 2, and the value of k is 2. So here, the length of the longest possible good subarray is 1, 2, 3, 1, 2, 3, because here the frequency of all the element 1, 2, and 3 is equal to 2, which is less than or equal to the value of k. So here the length is 6. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm, we have taken this example. The array contains 8 elements, which is 1, 2, 3, 1, 2, 3, 1, 2, and the value of k is 2. So here, suppose for this window, not this actually, for this window, the frequency of all the element is 2. Here, the frequency of 2 is 2, the frequency of 3 is 2, and the frequency of 1 is 2. So, we can say that this is one possible largest subarray where the frequency of all of the elements presented in the subarray is less than or equal to k. Now, how can you solve this problem? Here, first of all, if any of the problem we have to deal with the frequency, we have to simply use the map data structure, and map is really helpful here. And if any of the problem, we have to find the length of the longest subarray or deal with any of the subarray, which is a contiguous part of the array. In most of the cases, those kind of problem can be solved using the sliding window technique. Now let's see how can you solve this problem by using the sliding window technique. Now here, for a sliding window, we are taking a variable size window. Suppose the window size is this. So the frequency of 1 will be 1. Now the window size is this. So the frequency of 2 will be increased by 1. Now here the window size is this. So the frequency of 3 will be 1. So here for this window, the frequency of 1 is increased by 1 again. For this window, the frequency of 2 increased 1 again. And for this window, the frequency of 3 increased 1 again. Now, for this window, the frequency of 1 is becoming 3. But wait, the frequency of 1 or any element in the window must be less than or equal to k. So, we cannot consider this element 1 anymore. That's why we cannot consider this window, and we have to shift or shrink the window. Now, the window is this. So, we have to decrease 1 from the subarray. Oh, sorry, from the map. Now, so far so good. This window can also be one of the desired window because all of the element frequency is exactly 2 and the length is 6 here. Now, let's expand the window. And if we expand the window, the frequency of 2 becoming 3, so we cannot consider it. We cannot consider this window here, so we have to simply shrink our window. Now our window is this 312, 312. Here, all of the element frequencies is 2, so we can consider this as one of the possible subarray. Now, we have completed the iteration because the right pointer is reaching the last element. Now, here, the maximum window size we have got is 6. 1 6 here, another 6 here, and another 6 here. So we can say that for this problem, according to the sliding window technique, the maximum length subarray, which has the frequency of all of the element less than or equal to 2, which has the length 6. Finally, we have to return 6 as well. And the overall time complexity of this problem is big O of n. I hope you understood the problem statement as well as the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named max length. Here, we are given a vector and k as a parameter. Now initializing the answer and I and j with 0, and we are taking a map. Now, we are running a loop until the j pointers become out of bound, and we are increasing the a of j value into the map. And here, while map of a of j element is greater than k, that means our corresponding right pointer value's frequency is greater than k. So in this case, we have to try to shrink our window, and we have to subtract the a of I frequency by 1 from the map and shift the I pointer to 1 unit right. After that, if all of the elements has the frequency less than or equal to k, we have to simply upgrade our answer with the maximum of answer and window size, which is j minus I plus 1. Finally, we have to increase the window size by using j++. After that, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.